This is an overview of some of the sensors on the HAS200 and some principles of connecting sensors to PLCs. So the objectives of this section is for you to be able to describe the principle of operation of various types of sensors, also to be able to identify where some of these sensors are on the HAS200 and their purpose. Also to be able to take a wiring diagram of an HAS200 and trace the signal path from a sensor back to the PLC, and also be able to describe the difference between 2-wire sensors and 3-wire sensors, and with the 3-wire sensors the difference between NPN and PNP. And finally, given a data sheet, be able to look up relevant information about the sensor. So two basic types of sensors in terms of wiring. 2-wire sensors are simpler. They just generally consist of a simple set of contacts. And examples would be limit switches and magnetic reed switches. So there's just two connection points and they either conduct or they don't conduct. 3-wire sensors have got some active electronics in them. So two of the wires are just to power the sensor up, and then the third wire is to bring the output out to the PLC. There's two major types in terms of how the output is arranged, and NPN and PNP are the two types, and that reflects the type of transistor that's used on the output, and also determines whether when the output turns on, whether it's going to short to ground or whether it's going to connect to 24 volts. So let's talk about PLC inputs. So on a PLC, the inputs are grouped together into groups of 4 or 8 or 6 or whatever, it depends on the PLC. Each group of inputs has a DC common connection. And so the way it works is if you connect DC common to 0 volts, the voltage that turns the input on or makes it true is 24 volts, or it's usually anything above 14 volts, but 24 is a typical industrial DC power level. The other thing you can do is if you connect the DC common to 24 volts, then you can activate the inputs using 0 volts. So they work in either polarity. Once you've connected DC comm, though, to one of those two voltages, all the outputs in that group will be set to either activate from 24 volts or from 0. You can't have mix and match within the same group. So let's take a look at a situation with a 2-wire sensor where we've got 0 volts connected to DC comm. And so let's say it's simple. Well, this is not actually a sensor. I guess you could consider it a sensor. It's a push button switch. So you're going to connect the switch to the input. Now to make that switch work, you have to connect the common side of it to 24 volts. So when you push the button, 24 volts is applied to the input. Now if you want to connect another device, say to this other bank of inputs, that has a separate DC common. That would also have to be connected in order for this to work. And so also this switch would have to be connected to 24 volts. So that would be what they would look like with the switches open. The input is just floating there. There's no voltage applied. And then when the switches are closed, at 24 volts comes through and is applied to the various inputs. So those would be true inputs. If you connect the DC common to 24 volts, then take a push button. You'd also connect to the input. Then to make that push button give a true signal, you'd have to connect its common to 0 volts. So same thing if you had a limit switch connected to the other bank of inputs, you'd have to connect 24 to that common, and then the back side of that would be 0 volts. You could actually, between two different groups of inputs, you could connect one DC common to 24 and the other one to 0, but all the outputs, all the inputs on that bank would be this. You would have to have 0 volts or 24 volts depending on the common. So that's the switch is open, and when the switch is closed in this case, they are bringing the input to ground or to 0 volts, and that's what makes the input true. So now let's look at 3-wire sensors. First, looking at the PNP sensor. Now, if you look at the way the output is connected, the PNP transistor is connected to 24 volts. So when it turns on, it's going to apply 24 volts to the output. So in this case, we don't have a choice. We have to connect the DC comm to 0 volts because we know we're going to get 24 volts out of the sensor. So if it's a PNP sensor, first connection to the sensor is to just power it up. So 0 volts goes to the 0 volt pin and 24 to the power pin. Then the transistor output would connect to the input. But because this output is going to give us 24 volts when it turns on, we have to connect DC comm to 0 volts. So if you have DC comm at 0, you have to use PNP sensors. So when the sensor is activated, it turns the transistor on, and that creates a path for current from 24 directly through the transistor and into the input, which turns the input on with 24 volts. With the NPN sensor, we have similar connections. The 24 volt and 0 volt connections go to 24 and 0. The output connects to the input of the PLC. But because now when this transistor turns on, it's going to short that output to ground, we have to connect the common to 24 volts to work with an NPN sensor. So that's the equivalent of a switch connecting to ground or 0 volts. So when the sensor is activated, a transistor turns on, and we get connection from the input directly through the transistor to 0 volts, and that turns the input on. So most of the 2-wire sensors on the PLC are magnetic reed switches, and so they are set up on the pneumatic cylinders, and the pneumatic cylinders have a magnet mounted on the shaft so that as the cylinder moves from its extended to its retracted position, that magnet activates the magnetic reed switch sensors that are on the actuator. So when the sensor closes, when the switch closes, it applies 24 volts into the input and the input goes true. This is the electrical diagram for the Station 1 input module, and you can see here the magnetic reed switches. Those are the electrical symbols for the magnetic reed switches. On one side of those switches, they're all connected to 24 volts, and then the common for the bank of inputs is connected to 0 volts. Now there are 8 inputs that are connected to this common, and then the second common, DC common 2, connects to the next 8, which are, you see a couple of them here. So now when the magnetic reed switch closes, it applies 24 volts to the input and you get a true signal. The 3-wire sensors, there are a few of them that are optical type sensors. An optical sensor senses light, and the sensor will emit the light and look for any reflected light coming back. So there's 2 basic types. The diffuse reflective sensor emits light and then has a light detector right next to the emitter and is looking for any amount of light that's coming back bouncing off of an object. Another type of optical sensor is a through beam, where the emitter sends a light across a distance, and any object that comes between the emitter and the receiver will interrupt the light. So the examples of this, the maximum Q detector is a sensor that's put on each station to detect if the boxes have backed up on the next station. So what it'll do is it'll tell the PLC to stop putting boxes on the conveyor until the Q is reduced. So here's an example of the sensor on the conveyor belt, and if you get enough boxes in the line, they back up till they hit the sensor, and the sensor basically just tells the PLC station to pause until the box is clear. Now this is an infrared sensor, if you look at it with your naked eye, you don't see anything. This picture here down in the lower left was taken with an Android camera, which is actually able to see the infrared light. The same type of sensor is used on stations 2, 3, and 4 to sense if there's a box, or they call it a bottle in the documentation. If there's a box waiting at the input of the station, it will take the box from the input and fill that with pellets rather than grabbing one from its own stock. So it's the same basic idea. If a box gets in front of it, the sensor turns on and tells the PLC. So the other type of sensor, the through beam sensor, is used to detect if there are enough boxes in the box dispenser. This is a picture down below with the box dispenser removed, and the two sensors emit light in a straight line across, and they get picked up with a receiver that's opposite. And so there's two sensors. One of them tells the PLC that the boxes are almost empty, so that the second to last row is empty. And then once that last row is empty, the PLC gets the message that there are no boxes, and it has to pause until more boxes are put in. Another use of the diffuse reflexive sensor is the minimum material. So this is a sensor that can tell if there's a low amount of material in the hopper. So this one, the sensor itself is mounted down here, and it uses fiber optics to carry the emitted light up to the place it's being sensed and get the reflection back from that. Now this particular sensor is programmable. It's you can calibrate it to detect different levels of light, different shades of color. Well, there's 3 colors of pellets in the HAS200. There's blue, yellow, and red, and they all have different light properties. So the ability to calibrate these sensors is important to be able to distinguish between pellets being there and pellets not being there with different colors. Here's a section of the electrical diagram of Station 2 input module, and you can see these two sensors are the through beam optical sensors, the minimum bottles detector and the no bottles detector. This one here is the minimum material detector. That's the optical sensor with the fiber optic extension. And then these two are the bottle and line detector and the maximum Q detector. So each of these sensors has 3 wires. So the 2 wires that power the sensors are the 24 volt. So you see those connected to 24 volt, and the other wire is the 0 volt. And then the third wire goes to the PLC. And so you'll notice that because these are all PNP sensors, when they turn on, they're going to apply 24 volts to the input. So that means the common has to be connected to 0 volts. So the DC common is connected to 0 volts. So that means when the sensor turns on, activates, it allows connection from 24 volts through that PNP transistor. And so you get 24 volts at the input, and that's what turns it on. So there's a color code that's used, and this is pretty much an industry standard for 3-wire sensors. The blue wire is 24 volts, the brown is 0 volts, and the black is the output. So you'll see those color codes on the HAS200